kick off. My name is Greg Harris. I'm an assistant professor here at UC in the Department of Chemical and Environmental Engineering, and I'm affiliated with the chemical engineering side of the program, the department.
And I'm Dr. Drew McAvoy. I'm on the environmental side and also the undergraduate program director. So if at some point you're needing to substitute courses or, if you're even transferring credits, I'll get involved. I have to do the ultimate approval of those activities. So let me see if I can share my screen here and we can get started. Face out of the way too. Okay, so hopefully everybody can see this. Here we go. Hang on here, I've got faces everywhere. Okay, so you're at the Chemical and Environmental Engineering, this is and that. I'm going to start out, so I'm going to present the environmental portion, and then Dr. Harris will continue with the chemical, and then we'll have, I think, plenty of time for questions at the end. So environmental engineers, so you may be wondering, what do you need to know and what's your background? What kind of work do you do? So basically principles of engineering, soil science, biology, chemistry, all get involved with coming up with solutions to environmental problems. That's really what environmental engineers do. So it's really trying to solve environmental problems. So it could involve recycling, waste disposal. Actually, I should change that word, waste disposal. We don't deal waste disposal anymore. It's waste reuse. So waste can become a useful product. Public health, water, air pollution control are areas that you may get involved with. Global issues are of concern as well. So unsafe drinking water, climate change is really big, and just environmental sustainability. So if these are areas of interest, you may want into environmental engineering. So what do you study? Well, you're going to be studying math, computer programming, physics, chemistry, both inorganic and organic, biology. So these are all basic courses that you need to go on to take the upper level courses. Instrumental chemical analysis. So we deal a lot with chemicals in the environment. So need to know how to analyze them for assessments. Material and energy balance. So we need to understand energy flow and material flows in the environment and in treatment systems. Heat and mass transfer, fluid mechanics, and hydraulic systems is very important. Either air or water is a fluid. So we have to be able to transport these fluids from one place to another. Of course, chemical reactions. If we're looking at degradation of compounds, both in treatment and in the environment, which really leads to water and wastewater treatment, air pollution control, and then lastly here, water resources. And water resources is really understanding precipitation, runoff, river flows, and it gets into climate change and flooding and those kind of activities. Okay, so a lot of these are going to be very similar to chemical as well. There's a web page that you can go to, environmental engineering. So it really houses everything you need to know for applying and background on courses and that. So I encourage you to go ahead and go out to the website. Also, there's a guide. The web link is here as well. So it lays out what courses you should be taking for each semester throughout, the 4 years that you would be in class and in person. Hopefully we continue to be in person here. And just to make it a little more clear, just rearranging it here, these are kind of the focus areas that you would be taking courses in. Of course, there's basic science that you need to take just to, for understanding, and that's the chemistry, the physics. There's some geology courses, hydrology, and GIS that you would be taking. Of course, math, calculus, 1, 2, dynamic systems is really just differential equations. So math is all focused on calculus. In the middle there, you can see the environmental engineering. So about half of the courses you'll be taking, maybe not quite half, are in the environmental engineering discipline. There's some other engineering courses. Of course, your first year, the ENED courses that all engineering students take. And then there's some additional courses that are required, like sustainability and some tech elects. General ed, so this is to round out your undergrad curriculum. So here you take economics and some other elective courses. And then on the far right there is professional practice, and that's really dealing with co-op. So you'll go out 5 semesters during the 5-year period on co-op. So there are a couple, 1 and 2 credit courses that you would be taking. That's interesting. It just advanced, so I should move on. We have 3 focus areas: air quality, hydro systems, and water quality. So when you get to your 5th year, generally you focus on 2 out of 3 of these focus areas. And there's various courses that you could be taking to requirements for graduation. You may be wondering about minors. Several of the environmental engineering students do go and take minors, so you have to take additional courses. Probably the most popular is chemistry. Environmental engineering is a lot of chemistry, so students that like chemistry take on a minor there. Which is kind of related to environmental analysis. So that's actually chemistry in the lab where you're actually analyzing samples. Policy, so some students are more interested in environmental policy. Biological science, of course, environmental engineering deals a lot with biology. I found this interesting: Spanish. 2 students currently are minoring in Spanish, which is probably a good thing. It opens up the door for various things, and you can see communication, horticulture, math, and some other topics here. So you can, and you're encouraged, to take minors. Work environment. So you say, okay, what will I be doing once I graduate? Go out there and get a job. So most of the job, you're going to be working in either design of systems, control systems, either water, air, urban planners, you may work with them. Most of the time you're going to be working in an office type situation. But if you really like outside work, there's a lot of construction projects, because right now with the passage of the infrastructure law on the federal level, there's going to be a lot of construction of water treatment, wastewater treatment plants, sewer systems, water distribution systems. So the next 10 years, there's going to be a lot of construction going on. And if that's what you're interested in, there's going to be a lot of jobs in the future where you could spend time outside. Just a little bit on the numbers. Once you graduate, there's a fair number of jobs already. This was, a couple of years ago, 52,000, a little bit more. So there's a lot of environmental engineering jobs out there, and there's going to be, significantly more now, in the next 10 years because of the infrastructure bill. Median pay, 92,000. Again, this is a couple years ago per year, so not bad. Entry level, 68,000. Not quite as high as chemical engineering that you'll find here in Dr. Harris' talk, but not bad. Money's not everything, so you should really try to pursue something that you're going to enjoy doing, because you're going to be doing it 30, 40 years. Environmental engineers may not get paid quite as much as chemical, but if you enjoy the work, it really doesn't matter. Job outlook, again, with the new infrastructure bill, it looks good. I think this 4% is probably underestimate. I think it's going to be much more. Class of 22, so this is the current seniors. We have 30 students, and you look at the first year class, we're about 40 now. So relatively smaller class sizes compared to chemical engineering. Another difference between chemical is, so for environmental, you really don't need a master's or a PhD degree. You can go out with a bachelor's and get a really decent job, but most of the jobs you're going to end up needing to get a professional engineering license, a PE. But that's something that's a little different than probably what chemical engineers need. So instead of getting a graduate degree, you're still work experience and getting a professional engineering license. Okay, co-op. So this is the experience-based learning that we have. He is well known for it. It was one of the first to do it. Actually, I think we are the first back in 1906. So it's a very strong program, highly rated. So usually a draw for students. So if we look at environmental engineering, these are kind of the top employers for co-op. The Metropolitan Sewer District employs a lot of our students. You can see there's construction companies listed here. So again, out there in the field, actually, systems. Kroger, interesting. They do a lot of sustainability, energy work. They hire a lot of our co-op students. You wouldn't think of it, but the Ohio Department of Transportation, they have to do a lot of environmental work. If you're putting in a bridge or a new road, you have to do environmental assessments. So there's, US EPA, of course. If you're a research-oriented, undergrad, EPA is a good way to go. So you get experience in the lab. And I must say, you can also do research experience co-ops with faculty as well in environmental engineering. Just to give you an idea of the type of co-op opportunities that you would have. Just a little bit on research. I would say the biggest impact we have, it's really on the bottom here, areas is in water, energy, and the environment. So pretty much all of the faculty in environmental engineering, one way or another. We also have an environmental analysis service center. So here, we can analyze for a lot of different contaminants and even microorganisms, pathogens, and that. So it's a nice service, particularly for research, that we can do a lot of analysis. Student organizations. So here I've only listed 3, but you can get involved. There's like over 100 different student organizations at UC. These are probably the top 3 for environmental engineering students. So we have a Society of Environmental Engineers, do a lot of volunteer work in the community. One in particular is the Mill Creek Alliance, where there's a water sampling program. So participate in that. Engineers Without Borders. Again, this is, we haven't been able to go over to Africa last 2 years, but Tanzania, there's 3 different sites over there. In fact, Nabil one of the students that is here helping today. It's heavily involved with Engineer Without Borders, and I believe it's actually gone over to Tanzania. Is that correct, Nabil?
Yeah, I went over once in 2019 before the world kind of shut down on us.
So can you just talk a little bit about your experience in that?
Yeah, so I traveled with a team of about 15 students. We had a faculty advisor from UNT join us as well. And then for like 6 months beforehand, I had designed and went through the entire engineering process for a water system. It was about 2 miles of pipe, 3 tanks, 3 tap stands. And we spent 2 weeks traveling to Tanzania, working with community members, partnering with the local community there. And then we were able to establish a water system that currently serves 4,000 people with clean, safe drinking water that didn't have beforehand. And then I think since we installed it, it's distributed over 5 million gallons of clean drinking water, which is pretty cool.
Okay, great. Also, engineering CAS tribunal. So that's the student government for college engineering. And again, there's a lot of volunteer and social activities. So for the first two, Society of Environmental Engineer and Engineering Without Borders, it really goes beyond engineering. So a lot of, students outside of engineering participate. Let's see, I need to. So you get to interact with other students and other disciplines. So it's really good. I encourage you to get involved with student organizations. So I think most everybody, on the call today are transfer applicants, though I think there's some current UC students possibly as well. So this is just some websites that you can go and get additional information. I just, highlighted the transfer applicants here. So if you click on that link, this window that pops up and you can get a lot more information. So I'm just going to summarize here for the environmental engineering, at least, what's the this and that of environmental versus chemical. And at least in my mind, Dr. Harris may have a different take on it. But I look at least traditionally, chemical engineers are involved with synthesis and formulating chemistry into products that may be used for consumer or industrial uses. In that, where environmental engineers now, once these products are used, get discharged, and the environmental engineers then deal with the control of those chemicals that may get and do get into the environment. So depending on your interest, creating things or destroying chemicals, that's the two ends of the spectrum of where you would be with chemical or environmental. It's a technical degree. Some may be interested in environmental science. Environmental science is more involved with, understanding fate transport of chemicals in the environment, where environmental engineers focus more on control of the chemicals, try to, inhibit and control what chemicals would actually get out into the environment. Diverse opportunities after graduation, and, the pay's not too bad either. So any questions, I'm open. Here's my email address. Feel free to email me if you have any questions, and we can discuss them at that point. That's all I have. I'm going to turn it over to Dr. Harris. Stop sharing. And we'll have time at the end for questions, so if you can hold off on questions.
Yep. Do that now. There we go. So, like Dr. McAvoy did a very good introduction, kind of pointed out some of the differences. I'll kind of focus mainly on chemical engineering now. So just kind of a few numbers for you. the American Institute of Chemical Engineers. So that is the largest organization. That's going to be a big student group as well, AICHE. So the acronym American Institute of Chemical Engineers. Many students belong to that, but that has about 60,000 members worldwide in about 110 countries. And there's similar number or a few more employed as traditional chemical engineers out there in the workforce now. So my opinion as somebody with a background, I actually did my undergrad in mechanical engineering, then went and got a grad degree in chemical engineering, and then I did a postdoc after that in molecular biology. So take that number or that employed as traditional chemical engineers with a little bit of a grain of salt, because chemical engineering is just so diverse. So you may get your chemical engineering degree, and then you may not be a traditional chemical engineer, which I'll get into a little more. And that kind of goes for a lot of engineering disciplines too. That's not just chemical engineering. So the UC chemical engineering class of 2022 is about 122 students. So like Dr. McAvoy pointed out, the chemical engineering program is a good amount larger than the environmental program at this point in time. Chem grads don't need graduate degrees. You don't need a master's. You don't need a PhD. You don't need those other certificates. So generally, you won't need a professional engineer's license either. You can definitely get all of those, but they're not required to go get a job as a chemical engineer out in the workforce. So chemical engineering is all about math and chemistry, because that's generally what you'd think of coming out, you know, maybe even as a transfer student, but definitely as a high school student, you might think engineering is all about math and chemistry. It's not necessarily. So chemical engineering is going to use math. It's definitely going to use chemistry, but it's really applying all of those things that you learn about in those general education, your physics, your chemistry, your math, to solve problems. So that, again, I'm going to say, because I'm an interdisciplinary chemical engineer. So all of this is very interdisciplinary, but engineering is about solving problems at its core. So you have to want to solve problems to be an engineer. So I have the chemical engineering example of that, you know, making things in a beaker in the lab. You guys have probably taken a lab in high school, maybe your first year of college. But how do you scale that up? How do you make 25,000 pounds an hour of that stuff? You're probably not going to do that on your bench in your chemistry lab, right? It's just literally not possible. So kind of a real world example right now that we're dealing with on a day-to-day basis. How do you make 500 million doses of a new vaccine in a few months? There were a lot of chemical engineers and there was a lot that went into that. So chemical engineers were involved in scaling that process from the bench to manufacturing all of those vaccines. So, you know, if you don't have those chemical engineers creating those processes and helping out, you might have some problems, right? Engineers are very important there. Kind of a look at what you would think of as a traditional chemical engineer. You know, you have your distillation, your big old distillation column on the left-hand side there, your large-scale chemical reactors on the right there. So that's kind of what you would think. Go work in a chemical plant, right? Go work in a on petroleum or refinery. So those are definitely jobs that a chemical engineer can do. They employ a ton of chemical engineers. They are, you know, big co-op supporters. So a lot of people get co-ops there. But that's not necessarily the only thing a chemical engineer can do. So this picture, you would almost think a refinery is really pretty looking at this picture. The people who live close to it probably don't share that same view, but yeah, so that's a big employer of chemical engineers. But there's a whole lot more out there. So again, I'm going to say very interdisciplinary. So bioreactors, a lot of things. So a reaction, right? Chemical reaction, that's going to be a chemical engineer that could be working on that. A bioreactor, add in the bio portion. Bioseparations, so separating. And something you really might not think of, directed evolution. So genes, proteins, things like that. So directed evolution of enzymes here. An enzyme is just a protein that can catalyze a chemical reaction. So the person who kind of really jump-started this field won a Nobel Prize in chemistry. Dr. Frances Arnold, she was a chemical engineer looking at this directed evolution. So that is used now in a lot of fields. It's used in the pharmaceutical industry, production of renewable fuels, manufacturing of chemical substances, stemming from this kind of biology backbone there. So then there's your alternative energy sources. So you have fuel cells. The automotive industry is using a lot of chemical engineers to explore those things. Military applications, so coatings on jets, airplanes, whatever it is, chemical coatings, nanotechnology, all sorts of different things there. And then remote sensing, so the military, toxin detection, neutralization, medical diagnostics and therapies. So personally, I'm in a space where with my background, I do a lot of regenerative medicine. So I look at how to create biomaterials, how to use engineering to fix nerve injuries, attempt to fix nerve injuries, create therapies for spinal cord injuries, peripheral nerve injuries, which definitely you wouldn't think that's a normal chemical engineering job, right? So I do a lot of research in that area though, which incorporates chemical engineering principles into the medical field, really. Some of our capstone projects that the spring 2021 class went over, just so you can get a sense of what they're kind of doing as a capstone. Marketable products from waste materials. So those plants have waste. What do you do with that waste? You don't want to just throw it out into a stream or anything. So converting those products into something marketable. Marketable products from captured CO2. And you can see down the line vaccines. You know, we had one group want to look at vaccines for obvious reasons. And then usually we always have a group that will look at some kind of alcohol. Because if you think about it, so I live on the other side of the river in Kentucky. Bourbon down there is big, right? Bourbon, alcohol, beer. How is that made? Fermentation. That is a key chemical engineering principle. That is a chemical reaction to make that alcohol. So really, distilleries, I know, and I always forget, but there's a couple of the big distilleries down in Kentucky that actually have chemical engineers in kind of high positions because they understand all that, right? Really, they understand everything from the fermentation to the processing and just everything that goes on. A distillery is a real cool place to visit if you guys haven't. There's a lot of engineering principles that you can see all along the line. So where do chemical engineers work in their first job? Industry is an obvious one, continuing education, so going on to get those master's degrees, those PhDs. Government is another one. The government employs engineers. So the continuing education, yeah. Law school, med school are other ones actually. Medical school. If you are thinking about medical school, an engineer is actually very competitive for acceptance in the medical school. I don't know if anyone out in the audience is or not, but you differentiate yourself from the big crop of pre-meds. There's a big crop and you have to really be, you have to try to stand out. An engineer is going to be more altruistic because like Dr. McAvoy said, they make a lot more than a pre-med coming out of school. So the med schools know you're doing it for altruistic reasons and you can think critically. So yeah, talk to me if you want any more because I was considering med school coming out of college. So I have some thoughts on that, but engineers are very competitive for med school and law school as well. Industry, most of our UC chemical engineering graduates go to industry, and that is a function of our co-op program. It's just so great that most of them have job offers. So, if you have a job offer in hand before you graduate, it kind of sways them to go to industry. So a lot of them will go to industry because they're very well set up to go out and work in the workforce. where do they go work in their first jobs? So you can see kind of the graph there, 20%, a little under 20% do go into chemicals. So kind of that traditional chemical engineering job that you may think of, but really it's only like 18% or so that go out. The rest you can see along that line there, food and consumer products, biotech, pharmaceuticals, that's a big employer of chemical engineers, fuels, design, all the way down there. There's a lot of opportunities for chemical engineers. It's your traditional, I'm going to go work in an oil refinery, or I'm going to go. Definitely do not have to do that. What do chemical engineers earn? So this is broken down into years of experience. So that starting salary for a chemical engineer grad right out of your degree is about 75,000. I think it is, hovers around 75,000 right now. And then as you get more experience, obviously you're going to top out there. This is a couple years old, a survey from Chemical Engineering Progress. You're topping out a little over 160,000 when you get experience. But yeah, that starting salary is going to be around $75,000 generally. But what do chemical engineers study? Like Dr. McAvoy mentioned, these are going to be very similar for the first 2 years. Chemical engineers and environmental engineers, they have very similar curriculum. And then when you get into that third, fourth, fifth year, you'll kind of diverge and study a little bit different. So chemical engineers are going to study all those same prerequisites. They're going to study their math, their physics, their chemistry, all of that good stuff. And then as you get into kind of the upper stages, you will get into heat, mass transfer, thermodynamics is going to be a big one. Separations is going to be a big one. Like talk about distillation, your chemical reaction engineering, all of your key chemical engineering courses. So again, you need to be good at math, good at chemistry, but great at applying those to solve problems. That's going to be the key here. So a good chemical engineer has to be a fair chemist. You don't have to be an awesome A+ chemist. You just have to be able to apply that. Again, you can see that curriculum online. The page is right there. Go look up everything, all the classes and everything if you're interested in that. A snippet of that is just going to be your first couple of years here, where you really do take, all of those gen eds. So that first semester might just be English, math. You'll take your ENED, so your foundations of engineering, your first ENED class, and then you really get into some of your more chemical engineering classes as you kind of get into that second year, where you start to get into materials and energy balance. Organic chemistry is going to be important as a chemical engineer, and then your transport and things like that. So kind of you can see over on the side, those general education requirements can be transferred in. So for the transfer students, you can transfer in a lot of those gen eds and you don't have to retake them. If you haven't taken that ENED, those first year, just general engineering. So all of the engineering students across every discipline, environmental, mechanical, aerospace, chemical, all of them are going to take that ENED 1100 and ENED 1120. If you haven't taken those and you're transferring in, you might want to take a programming course before you start to get into those upper level classes if you don't have a programming course. So we have a lot of potential in our program for earning a Master of Science along with your bachelor's. So if you're interested in that, the Ascend program, you can actually do your master's and your Bachelor of Science in 5 years. So we have quite a few students that have actually taken advantage of that and are taking advantage of that. So with that bachelor's in chemical engineering, you can get a Master of Science in chemical engineering, Master of Engineering in chemical engineering, you can get an MBA. So a program where you get your bachelor's in chemical engineering and then a Master of Science in cosmetic science. That's with the pharmacological program. Common minors for these chemies. Really, like Dr. McAvoy mentioned, you can do whatever you want. If you can make the credits work, you can do Spanish, anything. The really common ones for chemies are going to be chemistry, because you literally need one more chemistry course So if you just take the chemical engineering curriculum as it is, you need one more course as an elective to get a minor in chemistry. So it's very low hanging fruit, you might as well almost. There's environmental engineering as a minor, materials engineering, mathematics, business, all of those are pretty common with our students. So a big range of opportunity. We've kind of talked about this. Grad school, all of the different things we talked about as far as chemies going out into the workforce, law school, business school, medical school, the government. The patent office is one that might not be obvious, but to look at all these patents coming in, getting submitted by people, I know a few engineers that have taken jobs there because they want somebody who can think critically about, okay, does this idea actually make sense? Is it going to work? And then can I look and compare it to what's already out there? Engineers are very good at that. So the patent office employs a lot of engineers. Specialties, our co-op is amazing. You can see our top co-op employers over there, BASF, Patheon, a lot of chemical companies there, Marathon, Dow Chemical, but it's really, unlimited. You can go wherever you want. Most of our co-op students are going to stay in a 250-mile radius from Cincinnati, but you can go find a co-op, and the co-op advisors are awesome. They will help make connections and, anywhere you would like to go, basically. So electives, you can specialize based on interest, and we have a pretty diverse chemical engineering faculty. So we have interests in separations, bio applications, energy. You can take environmental classes as a chemical engineer. That's perfectly okay. So very big range of options there. And if you are interested, definitely go look at some of the faculty. The faculty website will list kind of the interests to see if one of the faculty members has something that you're really interested in doing, and then reach out to them. They're happy to answer those questions. So in summary, chemical engineers are going to solve problems as well as most engineers. It's a pretty broad degree. So there are a lot of opportunities, diverse opportunities, applications engineers. So you could be in the field, you could work for a pharmaceutical company, a lot of different things. You could be in sales. Engineers that can talk to people are very, very valuable because you know the product inside and out. And then if you can talk and communicate that, you're going to do well in life. So like Dr. McAvoy said, the pay is pretty good as a chemical engineer too, and an engineer in general. So with that, my email is down there. Some of our leadership in the chemical engineering department is there, but feel free to reach out to me as well if you have any questions. That is what I've got. If we have any questions for either Dr. McAvoy or myself, glad to take them.
So if you do have questions for our presenters, don't be shy. You can put them in the chat box and we can read those out and have them answer. Or we would even love it if you went ahead and unmuted yourself and you can ask the question out loud as well. Any takers? Well, I think
Sure.
this is representative of how well of a job you did of covering all of these topics today. Everyone in today's session should have contact information for our presenters. They put that up on the screen for us. And of course, you can reach out to myself, our advising team. I'll put our email address in the chat. So if you do leave here, you start reflecting, you realize you actually do have some questions, we are here for you. Otherwise, I think we are in a good spot to go ahead and wrap it up for the day. Any final words from our faculty?
Thank you all for attending.
All right, awesome. I hope you all have a good day and a wonderful weekend. Take care. Bye now.
So
Bye.